Hello everyone, hope you all are doing well. So in this video we'll discuss the first problem of Leetcode BiWeekly contest triple one. It's an easy level problem, you can see that with the accuracy as well. But yeah, this problem can be made tough. I would say a much better problem if you increase the constraints. So first let's see what the problem statement is asking us to do. The problem name is count pairs whose sum is less than target. So it says that you are given a zero indexed integer array nums of length n and an integer target. Now return the number of pairs I comma j such that obviously I is less than j. Basically it means that you have to choose two distinct, what do you call it, pairs, right? And do not count them multiple times. That's what it says. I is less than j, okay? And nums of I plus nums of j is less than target. So find number of pairs whose sum is less than the given value. Simple. As you can see in this example, these are the numbers that we have, right? And the target is 2. So let's see what are the pairs. So if you see 0 comma 1, this and this, if you add them you get 0, which is less than 2. Similarly, if you choose 0 and 2, again you get 1, which is less than target. So this is the second pair. Then you get 0, you choose 0 and 4, right? Again that is 0, less than target, right? Now again, one thing to note here is there are three pairs, and it also says note that 0 comma 3 is not counted since nums of 0 plus nums of 3 is not strictly less, right? This is 0, 1, 2, 3, right? So minus 1 plus 3 is actually equals to target, and our condition is it should be less than target, right? Also, you have chosen 0 index and 1 index. Now do not choose first index and 0 index. That means count the pair only once, right? So that is why it says I less than j. Okay, this is what we need to do. Easy problem statement. If you just see the constraints, then a brute force will work, right? Run a nested loop from I goes from 0 to n minus 1. Similarly, j goes from I plus 1 to n minus 1. And for every I and for every j, just check that their sum is less than target, right? This is one of the solutions with time complexity of big of n square. Now if you want to solve it optimally, then we can go with some observations, right? The observations are, I hope you are a little bit familiar of how to solve the problem where we have to find the number of pairs, where you have, what do you call it, where the sum of a pair is equals to a target, right? This is sort of similar problem to that, right? If you haven't solved it, you can just watch that, right? You can just go through some editorials to get a better idea of that. I'll just tell you briefly how it is solved, right? So you are given some numbers, right? This is an array. Right now the numbers are out of order, right? So you just sort them. You just sort the numbers. Let me write the indices. These are the indices. I've just taken some random array. I've not written the elements. Suppose I have 8 elements, right? Now this is the smallest element of the array. This is the largest element of the array. You pick this element and you pick this element. You add them, right? You add them. Now suppose I'll take this problem, okay? I have to find the pairs whose sum is less than target, right? Now what are the cases? If I add this guy and this guy, right? If I add this guy and this guy, that means index number 0 and 7. Let's assume this is left index, this is right index. So if their sum is less than target, and the second option is sum is greater than equals to target, right? Now if their sum is less than target, that means this is the 0th element, this is the 7th index element, right? Now if I pair up 0th, so this is one pair, 0 comma 7 is one pair. But if I pair 0 with 6, 5, 4, 3, 2 or 1, then also it will satisfy my condition, right? Why it will satisfy my condition? Because suppose this value is x, this value is y. Now if x plus y is less than a given value, let's call it target, then x plus any value smaller than y, these values are smaller than y, will also be less than equals to target, right? So whenever this condition is satisfied, what I do, how many pairs am I forming? I am forming, if this is right index, this is left index, then right minus left are the number of pairs, right? How? 1, 2, 3, 4. Suppose these are the 4 elements. This is left, this is R. So how many pairs are we forming? Left is forming one pair with this, second pair with this, third pair with this, right? So this is 0, 1, 2. So 3 pairs means 3 minus 0. That is why R minus L. Getting it? Now the second condition is if your condition is not satisfied, right? If the sum that you have is greater than equals to target. Now if your sum is more from what you want, what you'll do, you'll try to decrement number, right? You'll try to decrement one of the numbers of the pair, right? So in that case, what we'll do, we decrement r minus minus, we move here, right? R minus minus. Also in the previous case, in this case where sum was less than target, I added all the pairs which this left was forming, so I increment L as well, right? Because now I have calculated all the pairs that L was forming. Now let's increment L. This was the first condition. Second condition, where my target is less than the current sum, I need to reduce the sum. So I'll reduce R, I'll move left, because in this direction the values are decreasing, right? I'll not change L, because if I change L, the value will increase and hence the sum will, the magnitude of sum will increase further. However, I want it to decrease, right? So that is why. So these are the only conditions and you can solve it optimally. The time complexity for this guy will be big of n log n for sorting plus n for traversal, right? Let's see the solution. This is the numbers, this is the number array that I have. I just sort it. Left index, right index, number of pairs is 0, right? While left is less than r, what's the current sum? Sum of left and right index. If my current sum is less than target, that means yes, there is a pair being formed, right? But how many pairs are being formed with this L? That is r minus L, right? Now you must be thinking, if the L and R are adjacent, then one pair is being formed, so r minus L will be equals to 1, right? So r minus L and increment L, because move to the next element, right? Because you have already calculated all the pairs which are being formed with the Lth index element, right? So that's why L plus first. Else r minus minus. Else means the sum that you have right now is greater than target. You need to decrease the sum, so r minus minus. Simple. A big of n loop, and finally you get all the answer, right? So these are the two solutions. First one is a nested loop. The second one is, this is how you can solve the problem, right? By just sorting it. Now since the time complexity is big of n log n, even if the number of elements is in the range of 10 raised power 6 or 10 raised power 5, then also you can use this solution and you'll get accepted, right? However, the nested loop solution will not work when you have higher constraints, right? The moment you go beyond 10 raised power 3, you'll get TLE, right? So that is why this solution will be helpful, right? So yeah, that's it for this video. I hope you learned something new from this video, right? Do support it by giving a thumbs up. Do subscribe to the channel as well. In case you have any issues related to the solution, any queries which is bothering you, mention that in the comment section. I'll revert on each one of them. Thank you. Take care. Bye bye.